Hi guys. Today we're going to go over Unit 7, which is over radicals and rational exponents, how you can go back and forth between the root and the exponent. And it's kind of a little tricky, but you've done this before back in Algebra 1. So just know the names. The index is that number right there that goes on the root. The number under the root is the radicand, and you have, of course, the radical. The default is always 2. That's why we're used to the square root. So when you just have the square root, that's why it's the default. So what does it look like? So here are our examples. So here we know the square root of 16 is 4, but why? Well, the index right there is 2, and I know 4 squared is 16. And the kicker here is when the exponent and the index are the same, we can simplify. That's why square root of 16 is 4. Now, 27 is a perfect cube. The index right there is 3. That's the index right there, the little number from here that you just learned. It's called index. So the index is 3. So 3 cubed equals 27. So 3 times 3 is 9. 9 times 3 is 27. So 3 cubed is 27. Cube root of 27 is 3. Because when the index and the exponent are the same, we can easily simplify that down to 3. So this 3 is this 3. This 3 is the index. Next one, we have the index is 5. And if I rewrite 2 to the 5th power, I get 32. Because 2 times 2 times 2 times 2 times 2 is 32. Index and exponent are the same. Therefore, cube root of 32 is 2. Now, I cannot take the square root of a negative number. From the previous units, you know the square root of a negative number is going to be imaginary. So I don't have any real root because it's imaginary, because I'm taking the square root of a negative number. And 2 is the default for the index right there. 81, right here, this 4 means that that's the index 4. 81, if I rewrite 81 as 3 to the 4th power, I get 81. When the index and the exponent simplify, voila, I have 3. So you get it. This negative right here goes there. This negative is this negative. 4th root of 1 is just 1. And this 4 is the index. Because it's telling us to determine the index and then evaluate. So I have negative square root of 121. 121 is a perfect square. Take the square root of 121, I get 11. This negative is this negative right here. The next one, the index is 3. And you're like, oh, it's going to be imaginary. No, we only have imaginary if this was a square root. But this one is not a square root. This is a cube root. So I will split that up. I'll rewrite as cube root of negative 1 and cube root of 125, because negative 1 times 125 is negative 125. Okay, that's why I'm able to split that up in 2 roots. So cube root of negative 1 is always going to be negative 1 because it's an odd index right there. And 5 times 5 times 5 is 125. Or I can simply rewrite 5 to the power of 3. Exponent, index, match. That means I can simplify. So this 5 will come out of the root. I have negative 1 times 5 is negative 5. Now in this page, we're going to go back and forth between the fraction on the exponent and the radical. That's what we call rational exponent. Rational, it's a fraction. Okay? Notice that whoever is on top is always going to be on top. M is on top. Top means the exponent. That's how I remember. And then N is the denominator. That's going to be your index. And you can put the exponent right there outside or right there under the root. Either way. Okay, so we need to rewrite that and then evaluate. So I'll rewrite this. 1 is the numerator right there. 2 is the index right there. So I went from the rational exponent to the radical. okay? And then I need to simplify because 2 is the default for the index, so I don't have to write it. And 1, you know, you don't have to write the 1 on the exponent, so just simply square root of 3. So here I go. I need to rewrite cube root of 27 as a rational exponent. So there's an invisible 1 right there on the exponent, is right there. The index goes right there on the denominator. So 27 to the power of 1/3. And then I need to simplify, right? So I go 3 cubed, 3 times 3 times 3 is 27. And then I had to rewrite right here. So 27 is 3 cubed. Simplify the index and the exponent down to 3. And that's pretty much all we're doing in this page. This one, I had a lot of questions over this one. So I might need a side paper right here. Okay, so we already know how to go from, I'm going to zoom in, how to go from rational exponent to the radical. So the numerator is now the exponent. The denominator is now the index. Okay? So now, when we think about what 2 to the 5th power means, I have 2 times 2 times 2 times 2, 1, 2, 3, 4 times 2. I know if I rewrite this with the exponent 3, I'll be able to simplify that exponent with the index. That's why I did this. So I'm rewriting the cube root of 2 to the 5th power as cube root of 2 to the 3rd power, because I know if I match, I'll be able to simplify them. But now I took care of these 3. I need to take care of these 2 others. So cube root of 2 squared. Okay, so now I can simplify exponent and the index. I simplify that. I get 2. And I know 2 squared is 4. So 2 cube root of 2 squared is 4. That's how I went from here to here. That's my thought process right there. This one, 64 is a perfect cube. So you just rewrite that like that. 216 is a perfect cube. This one right here, cube root of 8,000. If you rewrite as 8 times 1,000, 8 is a perfect cube. 1,000 is also a perfect cube. Cube root of 8 is 2, because I can simplify the index and the exponent. And same thing here. 10 to the 3rd power is 1,000. Simplify that. So now I'm left with 2 times 10, which is 20. The exponent rules, that goes back to middle school, maybe 6th grade. I don't know, because I don't teach that level. But I have a little cheat sheet here. So when you multiply with the same base, you add the exponents. So I have a couple examples here. When you divide the same base, you subtract the exponents. Power to another power, you multiply the exponents. This is just a little cheat sheet. Now, when you have a negative on the exponent, negative exponents mean reciprocal. So that goes down to the denominator, or like if it's just a whole number, that becomes a fraction. Okay, but means reciprocal. And to some of you, you're like, I don't even know what reciprocal means. So let's say that I have a fraction of 3/4. The reciprocal of that is 4/3. You just turn that fraction upside down. Okay, that's reciprocal. We already talked about this, how you can go back and forth between the rational exponent to the radical. Here there's some examples. And this extra one, I just threw it out there because we will get to the point that we need to simplify or solve equations. Some of you might not remember the power of 0. Anything raised to the power of 0 is 1. We already talked about all of them. This one might seem like it's common sense, but you can go back and forth between putting them together under parentheses and then raising everybody to that exponent, or breaking it up into like being the numerator and the denominator. And same thing right here. Going over some examples here. This one, I'm just literally applying the laws of exponents from the cheat sheet that we just had right there. So I have 9 squared raised to the power of 1/3, power to another power you multiply. 2 times 1/3 is 2/3. But this doesn't mean anything to me. So you'll have to go back and rewrite this as a radical. So the top remains on top, or this is the exponent. And then the denominator, that's your index. So now 9 squared is 81. Boom. The next one, we need to simplify. So the quotient rule. So when you divide, you subtract the exponents. I have a 1 right there for this one, invisible 1 right there. And then you subtract 1/4, you get 3/4. And then you rewrite, and then 6 to the power of 3 is 216. This one, power to another power you multiply. So 4 times negative 1/4 is negative 1. And then 4 times negative 1/4 is also negative 1. So negative reciprocal, negative exponent means reciprocal. So I need to turn that fraction upside down. So this goes on top, this goes in the bottom. So 10/8, but you know you need to simplify that fraction. So 5/2. Now, this question, you have a bunch of different ways to go about this. But for me, the easiest one was to deal with that negative first. So the negative exponent means reciprocal. That's why this ended up in the numerator with the others. But I took a bunch of steps at once. This is not algebra 1. That's why we do a whole bunch in one step. So I'm multiplying this 2 times this negative. I got the negative 2. And then I'm applying the product rule to where I'm multiplying, therefore I'm adding the exponents. So negative 5 plus negative 3 is negative 8. And I also dealt with this negative right there. That means reciprocal. And then I need to apply the product rule again over here with what I have. So negative 2 times 2 is negative 4. Negative 8 plus 3 is negative 5. Negative 5, negative exponent means reciprocal. So the x that I had from the product here goes in the denominator right there because of the negative exponent. This is just the same idea. Now 5 divided by 25 is 1/5. So I don't need to write a 1 right there, but the 5 is there. I apply the quotient rule. So 2 minus 1 is 1. 1 minus negative 2 is negative 1 for S. 1 minus negative 2 is positive 3. So that's there right there. And then negative 3 minus 2 is negative 5. So t to the power of negative 5, reciprocal, so that goes in the denominator. So I'll make another video for the next pages.